Hello, welcome back to the channel. So let's move on to a new concept which is known as the concept of separable differential equations. So we'll use all the concepts of integration that we covered in the last videos to get a good idea about separable differential equations. And a separable differential equation is an equation which is basically of this form. So whenever you have an equation of this form where you can simply move the similar variables on one side, that equation is known as a separable differential equation. So for example, in this case, if you have an equation which looks like, so if dy by dx is equal to a function of x times a function of y, if you have a differential equation of this form where you can easily separate the y variables on one side and the x variables on the other side, that equation is known as a separable differential equation. And the approach we use to solve these differential equations is we move the similar variables to one side. So the dy side will have all the variables in terms of y, and the dx side will have all the variables in terms of x. And then we integrate both sides and then calculate the solution to this integral. And then you have to make sure that since you're calculating an indefinite integral, you also have to add the constant of integration at the last. So now based on the concept of separable differential equation, let's solve this example over here. So we have to solve this differential equation, and you can clearly notice that we can separate these variables, right? So we can keep the x variable on the right hand side and we can shift e to the power minus y on the other side. And if we do that, is this differential equation is basically dy by dx equals x e to the power minus y, and we can separate the similar variables on each sides. So dy will have all the variables in terms of y, which is e to the power minus y, and we can shift this dx to the other side, so it would be x times dx in this case, right? And now we can integrate both sides, and then once we integrate both sides, we'll get the answer or the solution to this differential equation over here, which is a separable differential equation. So the left hand side is basically calculating the integral of e to the power y dy, and the right hand side is integral of x dx, and you already know the integral of both of these functions. E to the power y will be e to the power y, and x squared by 2, since we have to add the constant of integration, it doesn't matter if you add the constant of integration on this side or this side, because the constant of integration is a real number, right? It can take any real value. So usually what we do is we add the constant of integration on the x side. But also please note that it doesn't matter if you add the constant of integration to this side or even both sides, because you know that c can take any real value. So usually for simplicity we add the constant of integration to the x side, so the x variable side. And now if I have to simplify this equation, I can take the natural log on both sides. If I take the natural log on both sides, it will simply be natural log of e to the power y will simply be y, and the natural log of the right hand side will be equal to natural log of x squared by 2 plus the constant of integration, right? And also there is one more important point about the separable differential equations, that whenever you have the separable differential equations of this form, dy by dx equals f of x times g of y, you know that you're dividing dy by g of y. So you also have to make sure that your g of y is never equal to 0, because if g of y is equal to 0, this expression is not defined, right? So that is an important point that you have to also consider. In this case, you notice that it's dy by e to the power minus y, and you know that the exponential function can never be 0, right? So that is why we didn't have any constraints on this equation over here. But usually whenever you will be dividing a function on the dy side, you have to make sure that the denominator is not zeros. So you'll add your own constraints in order to ensure that your denominator is never equal to 0. Don't worry about this. We'll cover this example in the next video, which will give you a good idea about what we mean by constraints. So now you have this equation over here, and usually in order to calculate the constant of integration, you are always given an initial value. So a differential equation is basically a collection of the differential equation term and also the initial condition. So what this initial condition means is, you know that you got your answer in terms of x, right? So y is basically a function of x in this case, which is ln of x squared by 2 plus c. I'll move this equation down so that it's easier to visualize. So now you know that you got the solution to this differential equation as this expression over here, and what this means is, what this initial condition means is, when your x is equal to 0, because you have y of x, when your x is equal to 0, your y is equal to 1. So your function value is equal to 1 when your variable, your x variable is 0 in this case. So if we substitute that, if we substitute x equals 0, when x equals 0, y of 0 is equal to 1. So it basically means is 1 equals ln 0 square by 2 plus c, and then 1 equals ln c. So c is basically, if we take the exponent on both sides, c is basically equal to e in this case, right? So now the final answer to your differential equation, the final function solution to your differential equation will simply be equal to ln of x square by 2. So this is y of x equals ln of x square by 2 plus e in this case. So that's it for this video. Again, the main takeaway of this video is that whenever you have separable differential equations, you always have to move the similar variables to one side. So dy will have all the y variables, dx will have all the x variables on the other side, and then you have to also make sure that the expression, the denominator on the dy side is never equal to 0. In the case of separable differential equations, you'll also have to add your constraints as well. If some values of y will not be defined for this expression, we'll cover this concept in the next video as well. And then you'll basically integrate both sides and get the final solution. And usually in the cases of differential equations, you're always given a differential equation and an initial condition as well. So based on the initial condition, you can use the initial condition to calculate the final function. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.